Good evening, everyone. We are from Group 3, which supports the issue of prioritizing genomic surveillance of wildlife in African countries to prevent the occurrence of zoonotic diseases. This group consists of me, Saleh Warsai from Chad, and Haruna Suleiman from Nigeria. This is a crucial question for the future of public health and biosecurity across the continent. Africa has unfortunately witnessed several devastating zoonotic outbreaks, including Ebola, Lassa fever, and COVID-19. Many of these outbreaks originated from wildlife. Zoonotic diseases are transmitted when pathogens jump from animal to human, often during close interactions. What's more, Africa's wildlife harbor a vast reservoir of undiscovered pathogens, some which the potential to cause the next global pandemic. In example, the Congo Basin. This is one of the examples of hotspots for the emergence of zoonotic pandemics. By extension, we also consider the Ganges region in India, Southeast Asia, and the Amazon. Together, these form the endemic focus. Genomic surveillance offer a proactive solution by using advanced genetics tool. We can detect these threats early, often before they reach human populations. This early warning is essential for timely and effective public health response. It is observed among the global maps of zoonotic disease occurrence that the figures show all of the sub-Saharan African marked by red-orange zone, indicating a very high risk of zoonotic disease emergence compared to the green area where the risk remains low. So, we strongly affirm that genomic surveillance of wildlife must become a national priority. The consequence of inaction, both in terms of human sufferance and economic losses, are far greater than the cost of prevention. Zoonotic is not longer a luxury reserved for wealthy nations. It is a necessity for African health security. Africa must take a leading role in preventing the next pandemic. By monitoring wildlife genomically, we gain the power to detect, monitor, and respond to threats before it's too late. This is a vital not only for public health, but also for environmental protection and economic stability. So, the evidence improvement element indicates that a genomic technique targeting the pathogen sequence such as multiplex PCR and many other not only serve to detect the pathogen early before it impacts human, but by extension form an arsenal of early warning system. We noted the example where the identification of new coronaviruses in bats has helped researchers to develop a vaccine platform. Therefore, there's effort or being strained to provide key and strategic information. For instance, the incidence of a disease, an example, for the implementation and improvement of public health system, which the aim of targeting control and monitoring deployment, vaccination campaign, and any other preventive measure aimed at mitigating the risk of contagions. So, the prioritizing of genomic surveillance of wildlife involve environmental health surveillance, which represent one of the key points of the One Health concept, a global and immediate collective awareness of the link between human, animal, and any other environment aimed to combating major health threats. It's aligned with the WHO action plan for 2022 to 2026. Regarding the long-term the economic damage caused by COVID-19 in Africa resulted in a decline of GDP of 5.7% and a slow and effective political response are leading to losses amounting to billions for the continent. I will conclude my presentation with the last point, which addresses the priority implementation of genomic surveillance, also opening the door to strengthening the local capacity where expertise promotes the construction of a multidisciplinary research infrastructure, ensuring biosecurity and ownership of generated data.
Now to rebuttals. My opponent claimed that Africa faces more urgent health crises like malaria, maternal mortality, and genomic sequencing or genomic surveillance is a luxury. Genomic surveillance is not a luxury, it is a foundational tool for epidemic preparedness. The 2013 to 2026 Ebola outbreak in West Africa exposed the danger of ignoring zoonotic spillovers. The lack of early warning systems cost over 11,000 lives and $53 billion in economic losses. Genomic tools could have enabled early detection from wildlife hosts such as bats. In Uganda, which faces high malaria and maternal mortality burdens, the Uganda Virus Research Institute has successfully integrated genomic surveillance into routine public health strategy without sidelining other priorities. This shows it is not an either-or situation, it is possible to prioritize both. My opponent further argued that wildlife genomics is expensive and unsustainable given Africa's current infrastructure and capacity. I now rebut by saying the Africa CDC Pathogen Genomics Initiative, launched in 2020, has rapidly scaled genomic capacity across the continent. By 2024, 53 out of 55 African Union member states had sequencing capability. Countries like South Africa and Nigeria now serve as regional genomic hubs, supporting neighboring countries and wildlife projects at lower costs. Further, wildlife-focused projects such as the PREDICT initiative 2009 to 2020 in Cameroon, Tanzania, and Uganda collected and analyzed thousands of wildlife samples at relatively low costs, demonstrating feasibility with proper international collaboration and national commitment. My opponent further argued that limited evidence of immediate benefit, that human behavior, not just pathogens, derives spillovers, and that genomic surveillance offers limited benefit. Genomic surveillance complements behavior-focused interventions by providing real-time molecular-level insights into pathogens. During the Mpox outbreak in Nigeria, genomic tracking revealed multiple virus lineages and undetected community transmission, prompting improved containment strategies. Moreover, in Côte d'Ivoire, genomic analysis of wildlife retroviruses helped map cross-species transmission patterns, leading to localized public health campaigns targeting high-risk human-wildlife interactions. My opponents further argued that genomic data may be exploited without benefit sharing under weak legal frameworks. Rather than abandoning genomic surveillance, strengthening regional legal frameworks like the Nagoya Protocol, which many African countries have ratified, ensures equitable benefit sharing. Kenya, for instance, implemented the access and benefit sharing regulations, which regulate foreign use of genetic resources and guarantee community rights. This argument actually underscores the need for regulated and nationally led surveillance, not avoidance of the practice altogether. And finally, my opponents claim that wildlife genomic surveillance faces resistance due to protected areas, cultural concerns, and logistic challenges. Community-based approaches are increasingly successful in Africa. In Tanzania, genomic sampling within the Serengeti ecosystem is carried out with support from local Maasai people through education, benefit sharing, and conservation agreements. And furthermore, One Health initiatives in Rwanda and Zambia actively engage traditional leaders in surveillance programs, ensuring ethical compliance and local acceptance while gathering essential data on zoonotic threats. To conclude, genomic surveillance of wildlife is not just about preventing disease. It is about securing Africa's future. We must shift our mindset from crisis response to crisis prevention. The safety of our populations, ecosystems, and economies depends on us recognizing the power of prevention. Africa cannot afford to wait. For public health, national security, and scientific leadership, genomic surveillance must be a priority. We now welcome any questions, clarifications, or contributions. These are the sources that informed our research, from peer-reviewed articles on zoonotic diseases and public health strategies to WHO and One Health publications. We aimed to ensure this presentation is grounded in current evidence and global best practices.